Good morning, students. Today's start zeroth law of thermodynamics is also known as law of thermal equilibrium. Also known as law of thermal equilibrium. That law states that two systems are thermally equilibrium. The two system means B and C separately equilibrium. In third one is added means that third one A also thermally equilibrium. Separately again thermally equilibrium with each others. That is called zeroth law of thermodynamics. That principle used thermometers only. Principle used thermometers. Next, first law of thermodynamics. First law of thermodynamics, conversions of energy. Conversions of energy only. That example, state 1 to state 2. That means internal energy, change in internal energy equal to energy of 2 minus energy of 1. That means final energy to initial energy is called change in internal energy. That last means del E equal to Q plus W. That G is the heat. That heat means either absorption or evolutions. Next, work. W means work done by the system or work on the system also possible. That is called first law of thermodynamics. Other statement of first law of thermodynamics. First one, energy particular type disappears. That means the equal amount of another type of must be produced. For example, reactant to product. Second example, total energy system and surrounding remaining constant. System and surroundings remaining constant. Third, energy can neither created nor destroyed, may be converted from one form to another. The change in internal energy, closed system equal to energy, the boundary of heat or work. The heat or work are two ways. Change in system, internal energy, that means del U. Next, mathematical statement of first law. Mathematical statement of first law, del U equal to Q plus W, equation number 1. The case 1, first case, the del U equal to 0. Change in internal energy will be 0 means that Q equal to minus W. In other ways, during the cyclic process, amount of heat absorbed by the system equal to work done by the system because negative value will be present. Next, case 2. Here, isocaloric process. Isocaloric process means del V equal to 0. From that equation, del V equal to Q plus W. So W explained means Q equal to Q minus P delta V. So delta V already 0. So QV delta equal to QV. In other ways, isocaloric process amount of heat supplied into the converted into the internal energy. Next, case 3. Adiabatic process. Adiabatic process means no change in heat. So Q equal to 0. That means del E equal to W. In where the other ways in adiabatic process decreasing in the internal energy. In case 4. Isobaric process. Isobaric process means P remaining constant. So del E equal to Q plus W. So del E equal to Q minus B delta V. That PV is the expansions. Next topic, enthalpy. Simple capital H. Enthalpy is the thermodynamical property. Thermodynamic property. That what is meant by enthalpy means H equal to internal energy pressure product of pressures and volumes. That is called internal enthalpy. It reflects the capacity of mechanical work and the capacity of releasing heat by the system. That means del H equal to del V plus B delta V. That is process initial to final state. Constant pressure will be the change in enthalpy del H equal to heat supplied to the constant pressure, heat symbol Q supplied to the pressure P in endothermic reactions. Endothermic reactions. The Q greater than 0 means positive value. Which one is positive? Del H is the positive value. Q less than 0 means del H value will be negative. The 1 mark side will be asked. Q less than 0 means del H also negative, here positive. Relation between H and U. The H means enthalpy, U means internal energy. So H equal to U plus PV in initial state. In initial state H1 U1 plus PV1, equation number 1. In final state H2 U2 plus PV2, equation number 2. Equation number 2, equation 2 minus equation 1. So H2 minus H1 equal to U2 minus U1 into plus pressure V2 minus V1. So H2 minus H1 means del H. U2 minus U1 means del U plus P. V2 minus V1 means del V. Equation number 3. Equation 3, first law of thermodynamics. First law of thermodynamics. First law of thermodynamics, you know the mathematical term del U equal to Q plus W. Equation 3, del U value substituted in equation 3. Equation 3 del U means del H equal to Q plus W plus B delta V. You know the work. Work means minus P delta V. You apply the value. Q minus P delta V plus P delta V. That Q is the heat, so pressure will be applied means QP del H. Del H equal to QP only. that minus B delta V and plus B delta V cancel. Qp is the heat absorbed at constant pressure at the heat content. Next, consider closed system. Consider closed system for reactant. Reactant initial state. PVI equal to NIRT. Equation number 1. For product, final state. PPF equal to NF RT. I means initial state, F means final state. Equation 2. Equation 2 subtract equation 1. Pressure V final minus V initial equal to N final minus N initial into RT. So pressure V final V initial means P delta V del Ng RT. Equation 3. Equation 3 will be substituted in equation 2. That means that del H equal to del U plus del Ng RT. That is the final equations. Next, enthalpy change for different types of reaction and phase transitions. First topic, standard heat formations. The standard heat formation is known as the change in enthalpy taking place 1 mole of compound formed from its elements present in the standard state of pressure. That is called standard heat formations. Next topic, thermochemical equations. Thermochemical equation only balanced. Equation only balanced. Equation only balanced means stoichiometric. Stoichiometric chemical equations. Stoichiometric chemical equation means you following points you have to remember. First one, that number of reactant equal to number of product. That means number of moles of reactant equal to number of moles of product. That is the first point. Second point, enthalpy change. Enthalpy change means delta H change in reaction means specified in the sign. That means delta H or sign means sign with a unit. Sign means positive and negative. Next, third point, chemical equation reverse means reactant to product, product to reactant. That is the reverse. Then delta H is also reversed. Delta H is also reversed and same sign and magnitude. And fourth point, the physical state of gas, liquid, solid, all are in bracket. That means G, L, S. In thermodynamical equation, multiply through the number, enthalpy change also multiply. In thermodynamical means here 2 means 2 2s are 4. 2 2s are 4. Product side also 2 2s are 4. That is the multiply numbers. And multiply numbers means enthalpy change also multiply. Next, negative signs delta indicated for the exothermic. Negative sign means exothermic process. In positive sign means endothermic reactions. Positive sign means endothermic reactions. For example, given one reactions. Hydrogen, how many hydrogen? 2 hydrogens. 2 hydrogens also gas plus oxygens also gas gives how many? H2O. Total number of hydrogen 4. So here also 4. Total number of oxygen 2. 2 sums 2. Here gas. The delta H values, how much means delta H RO? Delta H enthalpy reaction standard minus 967 4 kilojoule. That reversible process means that is the positive sign. That is a formation of water. Decomposition of water means the sign will be changed. Next, heat of combustion. The change in enthalpy system when 1 mole of substance completely burned in excess of air or oxygens. Denoted symbol del H C is called combustions. For example, methane. Combustion of methane means taking one test tube, methane gas filled. That burning means minus 87.78 kilojoule means mole inverse. All the methane gas will be burned. Molar heat capacities. Molar heat capacity means heat symbol Q directly proportional to the mass, and temperature also directly proportional to the, that means change in temperature. Change in temperature means T2 minus T1, that is called del T. That Q is equal to C into M del T. That is next C equal to Q by M del T. C is called heat capacity. C is called heat capacity. Next, C is equal to Q divided by M into T2 minus T1. Expansion equation. That M equal to 1 kilogram. 1 kilogram. T2 and T1. T2 minus T1 equal to 1 Kelvin. That means you apply the value means what getting C equal to Q only. That is referred to specific heat capacity. Refer to specific heat capacity. Specific heat capacity. Specific heat capacity. The heat absorbed by 1 kilogram of substance to rise to the temperature by 1 Kelvin at a specific temperature is called specific heat capacity. The specific heat capacity for 1 mole of substance called molar heat capacity, symbol Cm. They defined the amount of heat absorbed by 1 mole of substance to rise to the temperature 1 Kelvin. Unit of heat capacity, joule Kelvin inverse mole inverse. Unit of heat capacity, joule Kelvin inverse mole inverse. Molar heat capacity are expressed constant volume, that means Cv, or constant pressure at Cp. That according to first law of thermodynamics. According to first law of thermodynamics. First law of thermodynamics, U equal to Q plus W, or E equal to Q minus B delta V. That means W value applied. So Q is equal to U plus B TV. Equation number 1. Differentiated means del Q divided by del T at a constant volume equal to del U divided by del T and constant volume. So CV is equal to del U divided by del T constant volume. Equation number 2. So similarly, molar capacity of constant pressure also. So Cp equal to del H divided by del T constant pressure. Equation number 3. Cv means a constant volume. Cp means a constant pressure. Relationship between Cp and Cv for ideal gases. First, enthalpy. Enthalpy definition: H equal to U plus PV. Equation number 1. For 1 mole of ideal gas, PV is equal to nRT. Equation number 2. Equation 2 substituted in equation 1. H is equal to U plus nRT. Equation 3. For differentiating means del H divided by del T, del U divided by del T, that nR plus nR del T divided by del T. Now del H by del T means what used? Cp. Del U by del T means Cv used plus nR into 1. That cancel means 1. Next, come to outside. Cp minus Cv equal to nR. Equation number 4. That is relationship between Cp and Cv. Today video is mathematical statement of first law and relationship between enthalpy and internal energy and relationship between Cp and Cv. All are side by side. You have to writing practice. Otherwise, not understanding. So you have to practice